All right, this is 6.7 arc length. So let's review what an arc, what a measure of an arc is. The measure of a minor arc is equal to its central angle. So as you look off to the right at this picture, you have this arc out here. That's 120 degrees. Why is it 120? Because it's the same as its central angle. Okay, so that we already know. However, what we're going to talk about this time is the length of the arc. Okay, the length of the arc is equal to the distance traveled along the circle's circumference. So if I were to ask you how long, if you were to walk in a circle like this, how long is that? Well, you would just figure out what the circumference is, right? Which the circumference formula is 2 pi r. Okay, so you would do that. Now, I don't want a full circle. I don't want a full length. All I want is a portion of it. So here's how we're going to discover that. So let's start off by looking at these two arcs. You have this green arc and you have that blue arc. Okay, which of these do you think traveled the larger distance, the green arc or the blue arc? I think most of y'all would probably say that the blue arc would be a larger distance, because if I go from there to there, it seems shorter as we go from there to there. Okay, so the reason is because if we look at the radius from there to there, or compared to this radius from there to there, the radius is larger. If you go back and refer that to the circumference, which is 2 pi r, if you put a larger number in right there, well, obviously the circumference is going to come out larger, okay? And that's pertaining to the full circle. Now, how do we get just the measure of each arc, okay? Here's how you get the measure of each arc. So let's look at this pizza right here. This pizza, if I want to know how long the crust is from there to there, then I would have to use this length, arc length formula, okay? And it is related to the central angle, which is also the same as the arc. So as I look at this, let me get this color right here. This angle right here is X amount of degrees, which is the same as its arc. That's X amount of degrees. But we can also find the length of it, meaning like in inches. Like how long is this pizza crust in inches? How long is it all the way around? Some people want to know that. So here's how you find the length of each arc. You're going to take the circumference and you're going to multiply that by the measure of the arc divided by 360. Okay, which this formula should look a little familiar because you did this with area of a sector. You found the area of a sector once before and that was part of the formula. So there's two formulas right here. You can either look at the one on the left, which this is circumference right here, and then you times it by x over 360. This is the same formula, only this circumference is the other formula, pi times d. That's the same as circumference, and you still want to times it by x over 360. Okay, so we're going to use that formula and practice that on these next couple of problems. So let's look at the first one. So this first one, it says find the length of arc CD. So that's this one right here. Some people would say, well, how is it not the other arc? Because remember, the other arc is a major arc. So we're going to find the length of that one. So all we're going to do is we're going to do pi times diameter. I like using diameter because it's just one number. And then times 80 over 360. Okay. So I can leave it in the exact answer, or I can put it in an estimate. Okay. So remember, I'm finding the length in inches because that's what the radius is right here. So let's see, we have 6 that can cancel out with 36. 6 goes into 36 6 times. I'll have 8 on top, so that's like saying 8 over 6 times pi, which that reduces to 4/3 pi. And that would be the exact answer up here, 4/3 pi inches. Now, if it said to give the estimate, okay, which probably sounds probably a little bit better, then you would need to get the calculator and do that. So let me get my calculator. So 4/3 times pi is about 4.19 inches. Okay, so 4.19 inches. Okay, let's try this next one. It says find the length of arc RT. RT is so from there to there. Remember, we don't want to find the other one because that's what do you call it? A major arc. So we want the minor arc because it just has 2 letters. So the radius is 18 feet, and the degrees of this arc is related to that one there. Is it 30? Nope, it should be doubled because that's an in-scribe angle. So that's a 60-degree arc. So we're going to put 60 over 360 times pi times diameter. The diameter is 36. Okay, and again, if you like to use 2 pi r, you can use 2 pi r as well. All right, so now I'm going to reduce this right here. That cancels. Actually, I'm going to erase that. This 36 is on the bottom, this 36 is on top. That actually cancels out. And so really, the length of that arc is just 6 pi. So if it's asking for the exact value of that arc, it's 6 pi feet. Okay. If it's asking for the estimate, you're going to multiply 6 times pi in the calculator, and that's about roughly 18.85 feet. All right, let's try one more length problem. It says find the length, or no, it gives us the length of arc TV to be 12 pi. So I'm going to highlight that arc right there. So this arc right here from here to here. Now remember, it's the smaller arc. It's a minor arc. So you don't want to pick the other one on the opposite end because that's a major arc. So this is the arc that you want to use. So it says this length is 12 pi inches. I need to figure out what the diameter would be. So I'm going to put in my formula 12 pi equals pi times diameter, because I want to solve for the diameter. And remember, it's x over 360, but we didn't figure out what that x is. If this angle is 80, this arc can't be 80. Remember, it's doubled. So this is 160 degrees. So it's going to be 160 degrees over 360. And so now we're going to break down and solve for solve for d. Pi's cancel out, so that makes life a little easy. I'm going to reduce this to be 16 over 36, which that reduces to, because both of those are even, let's see, 8 goes into that 2 times, and is it 18, I believe? 18 goes into that 2 times. Actually, that reduces again, 1 over 9. So the 16 goes into 36 times. Let me double check that. No, that does not right. 8. Nope, I did it wrong. Let me go back and erase this because that's not right. Let's try this again. So 2 goes into 16 8 times, and 2 goes into 36 18 times. And then that reduces again to 4 and 9. There we go. 4 goes into that. 4 ninths. All right, so let's rewrite this and see what we have. We have 12 equals diameter times 4 over 9. We're almost there, so how do we get rid of the 4 ninths? I like to do that in one shot, And so what I'm going to do is I'm going to multiply by 9/4, and that'll cancel out on one end. Whatever you do to one side, you must do to the other. So if I multiplied by 9/4, then I need to do that to the other end. You'll notice 4 cancels out with 12 because it goes into it 3 times. So 27 is the length of the diameter. 27 inches. Okay, so these are 3 examples using length. Okay, let's move on to the next one. There's some other properties. There's so many properties with circles. That's why this chapter is pretty long. So there's 2 more that we're going to go over. Okay, here's the first one. It says the measurement angle formed by 2 intersecting chords is, and so let me show you on the picture first, and then we'll go from there. So this angle right here that I just highlighted in pink, that angle, which is X amount of degrees, that angle is related to its 2 intercepted arcs, that one and that one. Okay, and the reason it's related to those two is because remember these are vertical angles, so those two are going to be the same. Okay, that's X amount of degrees, and that's X amount of degrees, and they're related to both of those arcs. How are they related? By this formula right here. It's going to be 1/2 times the measure of arc AB plus the measure of arc CD, like that. Okay, the other way to write that would be the measure of arc AB plus the measure of arc CD divided by 2. Okay, because that means the same thing as taking half of it. So it's basically the average of those 2 arcs. Okay, same thing goes for this other side over here, or the other angle. This angle right here that I just highlighted in green, that is related to this intercepted arc and this one here. Okay, so basically you take the average of its 2 intercepted arcs. Okay, so let's write that in the conjecture. The measure of the angle formed by 2 intersecting chords is the average of its 2 intercepted arcs. Okay, so it's the average of its 2 intercepted arcs. And we'll do some problems using this conjecture right here. Okay, so you take the 2 arcs, add them, and divide by 2. Here's our second conjecture. It's kind of like 3 conjectures in one, but they're pretty all similar, so that's why I put them in one conjecture. Okay, so let's look at the picture first, and then we'll write out the conjecture. So we have arc X. So I'm going to highlight in red. Arc X goes from there to there. Okay, and then we have arc Y, which goes from there to there. So it's kind of like a big arc and a little arc, and that goes for all of these. So this arc right here goes from here all the way to those points of tangency. Arc Y goes from there to there, which you'll notice those 2 arcs occupy the full circle. But again, the red arc is the big one and the blue arc is the smaller arc. Same thing over here. This arc for X goes from there to there, and arc Y goes from there to there. Okay, those 2 arcs, again, red is big, blue is small. Those arcs are related to the angles out there in the exterior of the circle. You have angle 1 right there. You have angle 2 in the exterior, and then you have angle 3. Okay, so this one over here on the left is made up with 2 secants. Okay, this one here in the middle is made up with 2 tangents. That's what these lines are called, okay, or rays. This one over here is 1 secant and 1 tangent. I'm going to just abbreviate. Okay, so those are the pictures that you can work with. Okay? Sometimes it's hard to visualize these in an actual problem. So here's the formula though for these. What you do is you take the big arc. Well, you're going to take half again, okay, because it's almost kind of like the average. But you're going to take half of the big arc, and you're going to minus the small arc. Okay, so big arc minus small arc, and it's always going to be 1/2. Okay, same thing goes for this one. You take half of the big arc, which is X amount of degrees, and then you minus the small arc, which is what we call the Y. Okay, they're not going to always be called X and Y. They're going to be different values on your problems that you work with. Okay, same thing goes for the last one. You're going to take half of the big arc, and then you're going to minus the small arc. And that's how you get that. If you like to divide by 2, you can do big arc minus little arc divided by 2 as well. Okay, either one. So how does the conjecture go? The conjecture goes the measure of an angle formed by 2 secants or 2 tangents, or a secant and a tangent that intersect outside a circle is the large arc. Oops. Or actually, let me start over. Actually, I'm going to start off with half. Is half, because that's a big deal. Half of the big arc minus the small arc. Okay, now these are the intercepted arcs, that is. Okay, so it's the big intercepted arc, and we just don't have a lot of room on here, minus the small intercepted arc. So just keep in mind that they've got to be the intercepted arcs. Okay. All right, so now let's put these to use on some problems, and they can get pretty tough because it starts to look a little confusing with these circles. Okay, but it's the same formula for all 3. All right, so let's put that to use with this first one. What's the measure of angle 6? So you'll notice we have 2 tangents. This is a tangent, and this is a tangent. So I'm going to get my highlighter. This is like the big arc from there to there, and this is the small arc from there to there. So it's like saying the big arc minus the small arc. Okay, we do not know the small arc, but we can figure it out. Okay, we can take 360 because it occupies the full circle and do it that way. So if that's 260, obviously that arc right there is 100 degrees. So I can do 260 minus 100 degrees divided by 2, which that is 160 divided by 2, which is 80. So angle 6 is 80 degrees. Let's try it on this next one over here. This next one, we have this big arc right here, which is X amount of degrees. And then we have this small arc right here, which is 70 degrees. And that is related to this angle out here in the exterior. So let's write it out using the formulas. So we're going to have big arc, which is X amount of degrees, minus the small arc, divided by 2, equals 30 degrees. How do you get rid of the 2? Because we want to solve for X. I'm going to multiply by 2. Whatever I do to one side, I have to do to the other. X minus 70 equals 60. Add 70. And that's what X is. 60 plus 70 is 130 degrees. So X is 130 degrees. Over here, we have 2 secants. Okay, so remember the big arc is right here in red, and the small arc is right here. I don't know the small arc, and I got to solve for that angle. So I have to figure out what the small arc is. Well, I know almost the entire portion of the circle. So I'm going to take 360 degrees, and I'm going to subtract 110, and then another 200, and that leaves me with 50. So this little arc right here is 50 degrees. Okay, so now my formula is going to be 110 degrees minus 50 degrees divided by 2 is equal to my angle that I need. So 110 minus 50 is 60. Divided by 2 is going to be 30. So angle 5 is 30 degrees. Okay, so that's using the 3 properties that we just went over. Okay, let's try some mixed up. Over here we have to solve for angle 9, angle 10, 11, and 12. So let me highlight those in red. Here's 9, 10, 11, and 12. So if I figure out 1, I can figure out the other 3 because we have some vertical angles here in linear pairs. So what can I do with these 3 given measures, which are algebraic representations? I can add all of them and set them equal to 360. So I have 1, 2, 3, 4, 5. I have 5x plus 0, okay, which I don't need to write because we have 20, negative 10, negative 10. And so that's equal to 360. So divide by 5, and then I can know what x is, and then I can plug that back in. How many times does 5 go into 360? 72 times. So if I plug 72 in, then I can write down a representation for each arc. So let's do that. 72 minus 10, this arc is going to be 62 degrees. 72 plus 20, this arc is 92 degrees. This one over here is 72 degrees. And then the last arc is 144 minus 10, 134. So you can clearly see this is not drawn to scale, so you don't want to freak out once you see that, okay? It's like one of these small arcs is a really big number, and that's okay, just let it be, okay? So it's just not drawn to scale. Okay, now here's what a lot of kids will think is next. They'll say, oh, well, 9 must be 134, this one must be 72, this one must be 92, and this is 62. And I'm going to erase all that because that's all wrong. These are not central angles, okay? So you're relating it to something different, okay? They're not central angles. So let me get rid of all those numbers. Okay, the way they're related is, and I'm going to get the highlighter, this is the conjecture we just talked about. This angle right here that I highlighted in green is related to this arc and this arc right here. Okay, so what do we do with those 2 arcs? Well, we need to take the average of those 2 arcs. So we take 134 plus 92 and divide it by 2, and that's going to be my angle 11. So that's going to equal angle 11. So let me get my calculator and add those up. So 113 degrees. So this is 113 degrees, which you should know is the same on the other end because those are vertical. And then I can use the 180 rule because I don't need to do the average of those 2. I know from past experiences these 2 right next to each other are 180. So that's 67. And that's 67. And there I go. I have all 3 arcs. 9 and 10, 67. 67. 113. All right, let's go to this one over here. This one looks like a tough one. We have this angle here, which is 105 degrees. I have this arc over here, which is 95 degrees. And I have to solve for this angle right there, which is angle 5. Now, one thing I do want to mention is that this is an inscribed angle, which the inscribed angle is related to this intercepted arc. So if I can find this intercepted arc, then I can just take half of it, and that'll get me the inscribed angle right there, which is angle 5. So how can I get that arc? Well, you should notice that we have intersecting chords, which we just talked about that today. This angle is related to its 2 pink intercepted arcs. Well, this angle I know because this is 105, so that must mean this is 75. And so if that's 75 and this is 95, I should be able to solve for this arc over here, which I'm going to call x. So 95 plus x divided by 2 is equal to 75. And now I can solve for that. So I'm going to times it by 2, times by 2. I'm going to come over here on this end. 150 is 75 times 2. And that's equal to 95 plus x. So I'm going to subtract 95 from 150. 150 minus 95 is 55. So this angle up here, I'm not angle, this arc up here is 55 degrees. So since that arc is 55 degrees, you can always take half of that to get its inscribed angle. So 55 divided by 2 is 27.5. So arc angle 5 is 27.5 degrees. But you got to use the intersecting chords to figure that one out. All right, let's try one more big puzzle. I have lots of angles that were given. I got a couple of arcs. No, 2 angles or 2 arcs, actually. Okay, so I got to find the measure of AF. So measure of arc AF is right here. So I got to find that arc. I got to find EC. So EC is from there to there. And I got to find the measure of arc AB, which is from there to there. And then lastly, I'm going to find the measure of angle FBC. Where's FBC? Okay, so this one right here, I got to figure out what that angle is. And the last one, DCB. DCB, that's this angle right here from there to there, that big angle. So where do we start? We can start, I think the first easiest angle would be, and let me get my highlighter, would be with these intersecting chords right here. I have this intersecting chord and that intersecting chord right here, which are related to these 2 arcs, that arc and that arc, okay? So I'm going to get my pen and I'm going to take 48 degrees, add it with arc AB, divided by 2, and that should equal 68 degrees. So I'm going to times by 2, times by 2. 68 times 2 is 136. And so 48 plus AB, I'm going to minus 48 from 136. And I get 88. So this arc right here, guys, is 88 degrees. Okay, so that's my first easiest one. So this one is 88 degrees. All right, what would be the next easiest one? Well, I think the green arc would be good, and I see that there's a lot of busyness on here. So that's why what makes circles kind of challenging. So let me get my highlighter and try to use different colors. But I have this big secant and that one. Remember, that's related to this big arc minus the small arc right there. And so this big arc in green is, let me get my green pen. That big arc in green is 88 plus 72. So 88 plus 72 is 160 degrees. Okay, so that's 160. And 160 minus this small arc right here will give me that 46. Let me get my pen. I'm going to write it out up towards the top. It's 160 minus the small arc, which is EC, divided by 2 equals that angle out there, which is 46. So times it by 2, times by 2, 46 times 2 is 92. And 160 minus EC is equal to 92. I'm going to minus 92 from here, and that's going to equal EC because I'm going to move EC over here. So 160 minus 92 is 68. So this arc right here is 68 degrees. So EC is 68 degrees. Okay, I'm almost there. I should be able to get AF now because I almost know the entire circle, so I can just subtract all those arcs from 360. So let's do that one next. 360 minus 48 minus 68 minus 72 minus 88. And that leaves me with 84. So that arc out there is 84 degrees. All right, almost there. Now I just need the two angles. So the purple angle should be pretty easy because the purple angle actually is an inscribed angle, and that intercepts this arc from there to there. That's way too thick. Let me get rid of that. So this purple angle intercepts that one right there. So 68 and 48. 68 plus 48. That whole big purple angle out there is 116 degrees. So all I have to do is take half of that, and that's going to give me that inscribed angle. So divided by 2, that's 58 degrees. All right, one more angle to go. That's the orange angle. And so that goes from there to there, which intercepts that really big arc, or you can easily find, let me get another color, this angle right here, which is related to this small arc right here of 72. All I have to do is take half of 72, which is 36. And so this angle right here is 36. Well, you know that's a linear pair, so I'm just going to take 180 degrees and minus the 36. And that'll leave me with my orange angle, which 180 minus 36 is 144. So that angle is 144 degrees. So 144. So these puzzles can get a little tough, okay, because there's chords everywhere, angles everywhere, and it's kind of hard to see. You always want to focus on the angle and what arc it intercepts, so that way it can help you solve that. Okay, and that is it for this